Hello viewers and welcome to our today's class. Today we are going to be looking at our fourth question, of course, under simple stresses and strain. Now, the question says a steel wire 2 meter long and 3 millimeter in diameter is extended by 0.75 millimeter when a weight of W is suspended from the wire. If the same weight is suspended from a brass wire 2.5 meter long and 2 millimeter in diameter, it is elongated by 4.64 millimeter. Now, we are asked to determine the modulus of elasticity of brass if that of steel be 2.0 times 10 to the power of 5 Newton per millimeter square. Now, from this question, you can see that we have two materials. We have a steel wire and we also have a brass wire. Okay, so for this question, I'm going to be bringing out my data. The data be now. First thing first, we said a steel wire 2 meter long. Now, that is the length of our steel wire. I can denote it by L source with S to be equal to, I have 2 meter. Now, the diameter is of course 3 millimeter, so I can say my ds equals to what? It's equals to 3 millimeter. What we have next is extended by what? By 0.75 millimeter. That is the extension produced equal to 0.75 millimeter. Now, when a weight W is suspended from the wire, if the same weight is suspended from a brass wire 2.5 meter long, I'm going to have the length of my brass wire to be equal to 2.5 meter long and 2 millimeter in diameter. So my ds will equal to 2 millimeter, db, sorry, db equals to 2 millimeter. Next, what do we have? It is elongated by 4.64 millimeter. That is the change in length of the brass wire equals to 4.64 millimeter. Now, you have to determine the modulus of elasticity of brass if that of steel to be E, that is the modulus of elasticity, but of steel, that is with S, will now be equal to 2.0 times 10 to the power of 5 Newton per millimeter square. Now, this is what I have. So next, we are going to be solving this question. First, we are going to be using our relationship of modulus of elasticity, stress, and also that of strain. Now, we know that E is equal to, we have sigma all over E. You know that this is our first relationship for what? For modulus of elasticity, stress, and also strain. And we also know that E equals to our change in length all over original length. Also, we know that sigma equal to force all over area. Now, what I'm going to be doing is that I'm going to be substituting the values of stress and strain in this relation. If I do that, E will be equal to sigma in place of P all over A all over I have E, which is strain, will be equal to our change in length all over the original length. This, of course, will be nothing but P all over A multiplied by L all over my change in length. So this is what I have. So I'm going to be having E equal to PL all over A change in length. Now, what I'm interested in is my L. I'm going to be making the L the subject of this relation. If I do that, I'm going to be having, first I'm going to cross multiply. If I cross multiply, I'm going to have PL. I'm going to have PL equal to A change in length. Now I'm going to be dividing both sides by EA, what I have, implies that my change in length will be equal to EL, that is my load multiplied by my length, all over what? All over EA. Now, in the case of my question, which says a steel wire and a brass wire, I can write this formula as the change in length of what? Of S will be equals to P L of S. Of course, from this question, the weight is uniform, so P remains weight is I have L sub with S, that is for steel, and I have E, which is the modulus of elasticity for steel, multiplied by area. Now the area, of course, is going to be different because we have two different diameters. We have AS, this is for steel, and the formula for brass will be this. We have P, which is uniform for both. I have L subscript B, that is the length of the brass wire, followed by the modulus of elasticity of the brass wire, multiplied by the area of the brass wire. So this is what I have. Now, from this question, I'm going to be doing some conversions. I have millimeter here. I also have millimeter here. I also have millimeter here. I have millimeter here. So what I'm going to be doing is that I'm going to be converting this to millimeter, and I'm also going to be converting this to millimeter. How do we convert meter to millimeter? Of course, we multiply by 1000. If I multiply 2.5 by 1000, what do I have? I have 2500. So this is equal to 2500. If I multiply 2 by 1000, of course, I have 2000. Of course, this is millimeter and this is the. Now, from this formula, I have change in length S, of course, is equal to PLS over ESAS. So first thing first, I'm going to be substituting for this. I have our change in length S, that is our change in length for length, of course, S for B. Our change in length now for steel wire is equal to 0.75 millimeter. So we have 0.75 to be equal to our load, of course, is constant. Our load is constant, but we are not giving load here, so we just go with P multiplied by L subscript S. L subscript S from here is the length of the steel wire, which is equal to 2000 millimeter. So I have 2000 millimeter here. All over, I have E subscript S, which is the modulus of elasticity for the steel wire. It is 2.0 times 10 to the power of 5. So I have 2.0 times 10 to the power of 5. This is multiplying area. Now my area, of course, will be nothing but pi all over 4 into what? Into what? Into this square. Now the diameter for the steel wire is 3 millimeter. So I have 3 squared. So this is what I have. So next, I'm just going to make P the subject of that formula, of this equation rather. So if I cross multiply, I'm going to have P multiplied by 200 to be equal to 0.5, 0.75 rather, multiplied by 2.10 to the power of 5 into the bracket of pi by 4, 3 all squared. So this is what I have. I can make P the subject of this relation, of course, by dividing both sides by 2000. Of course, this is 2000. So if I do that, divide both sides by 2000, I'm going to be having, of course, 2000 cancel 2000. So P will be equal to, what do I have? I have 0.75 times 2.0 times 10 to the power of 5 into pi by 4, P squared, close the bracket. So I have P here to be equals to this. So I can, of course, it is all over 2000. Do not forget it is all over 2000. I can call this equation 1. So let's move to the next step. I'll clean this side and we'll move to the next step. For this relation here for brass, I'm going to be substituting my values. Of course, what do we have? We have the change in length for brass wire. The change in length for brass wire, of course, has been given to be 4.64 millimeter. So I have 4.64 millimeter. Yes, to be equal to what? P, of course, we are not given. We have the length of brass, which is equal to 2500 millimeter. So I have multiplied by 2500 millimeter. So this is what I have. So what do I have next? This will be all over. I have the modulus of elasticity for brass. Of modulus of elasticity for brass, it is not given. So we just have EB, E sub will be rather multiplied by the area. Because it is pi by 4 into the diameter of the brass wire, which is 2 millimeter, 2 all squared close bracket. So what are we going to do? I'm going to make P subject of this formula. If I do that, I'll be having, first thing I'm going to cross multiply. If I cross multiply, I'm going to have P multiplied by 2500 equal to 4.64 multiplying the modulus of elasticity of brass wire multiplying area, which is pi by 4, 2 or squared, close the bracket. Next, I'm going to be dividing both sides by 2500. Finally, make P the subject, 2500. So I'll be wiping this side and I'll be dividing both sides by 2500. I'm going with 2500. P will be equal to what? P will be equal to, what will P be equal to? P will be equal to 4.64 times EB, that is the modulus of elasticity of brass, multiplied by pi by 4 into 2 squared. This is what we have. All over what? All over 2005. So this is what we have. Have this be equal to P, and don't forget, this equation. Now, what do we have here? We have for our first equation P to be equal to this, which is load, and our second equation P to be equal to this. Now I can equate both equations. If I equate both equations, what will I have? I'm going to have 4.64. I have this to be all over 2000. Now from the question, don't forget, we are equating both load because it is said to be same. Of course, from the question, it said if the same weight is suspended from a brass wire, that is the weight for this brass wire is also the same weight that is used for the steel wire. So we are equating both weights from the question. So if we do that, this is what we have. Now, if you solve this, of course, mathematically, EB, that is our modulus of elasticity of brass, which we are asked to find, will be nothing but 0.909 times 10 to the power of 5 Newton per millimeter square. So we have 0. What? We have 0.909 10 to the power of 5 Newton per millimeter square. So of course, this is our modulus of elasticity of brass. All you're just going to do is to make EB the subject of the formula and just press your values with the calculator, and you're going to arrive. And from what we have just done, we have calculated the modulus of elasticity of brass, and this is the answer. So thank you for watching, and stay tuned for more videos.